So this is a video for homework 2, number 14. And one thing I wanted to show you is that how you can go through your question help in order to get the formulas that you need for the whole entire problem. So if you go to question help, and again, this is sometimes a little bit easier than going through the textbook to find what exactly you need to do, right? If you click view an example, it's going to go through step by step with very similar problem numbers, right, as to what you had to do for the entire problem. So the first thing is verifying that you can use the approximately normal distribution, and this is to verify that you have at least 5% of the population size, and then also that n times p times 1 minus p is going to be less than or equal to 10. Okay, or I'm sorry, greater than or equal to 10. I switched that around. Okay, so first of all, if we were going to go through this, we would need to have our little n, we need p, and we need big N. Okay, so this first condition is I want to make sure that little n is less than or equal to 0.05 times big N. So I want to make sure 75 is less than 0.05 times, in this case, 10,000, right? So if I go back to my calculator, let me just go to my calculator here. If I do 0.05 times 10,000, that's 500. So this meets the criteria because 75 is going to be less than or equal to this number here, 500. So that is met. The next thing we need to do is do n times p times 1 minus p. And again, make sure that this is going to be greater than or equal to 10. Okay, so in this case, my little n is 75. So we have 75. I need to multiply that by p and then times 1 minus p. So p is 0.8, so we're going to multiply that by 0.8. And then multiply that by 1 minus 0.8, which is 0.2. And I'm getting 12, right? So now this also meets the criteria because 12 is greater than or equal to 10. So we have that done. Now next, we say, okay, it's approximately normal. What we have here is the mean of the sampling distribution is the same as the population proportion. So notice here, when they started off that p was 0.7, that's also their mean for their sampling distribution. So for us, our mean started off as 0.8, and it's still that mean for my sampling distribution. Okay, now next we have another formula we have to use. This one is for standard deviation. It's not the same when it goes from the population proportion to the sampling distribution. What we have to do is we take our p, multiply by 1 minus p, and divide by little n, and then take the square root. So I'm going to do 0.8 times 1 minus 0.8, which is 0.2. Divide that by, I think my little n was 75. Yes, okay. Divide by 75, press equals, and then you can take the square root of this number. So square root of my answer. And that'll just do the square root of my previous answer. And I'm getting 0.046, and I think that's going to be a 2 because next to it's an 8, and they wanted us to round to 4 decimal places. So 0.0462. Let's see if I was correct. Oh no, they wanted us to round to 6 decimal places. So let's see here, 6 decimal places. 1, 2, 3, 4, 5, 6. So 0.046188. And I do have that correct, 0.046188. Okay, now next it says, okay, what's the probability of obtaining x equals 54 or more individuals with the characteristic? That is, what is the probability of p hat being greater than or equal to 0.72? Now to do this, you'll see here that we're going to be looking for the area to the right of p hat being 0.72. Okay, oops, sorry. So first thing we have to do is compute the z-score. So in my case, I actually want this to be 0.88, right? So I'm going to take my p hat, 0.88. I'm going to subtract my p, which is 0.8, and I'm going to divide by my standard deviation, which was the 0.046188. Okay, so 0.88 minus 0.8 divided by 0.046188. Okay, that's a lot. I may have to click back and forth a little bit to remember all these numbers. So let's see, I'm going to go over here, clear this out. So 0.88 minus 0.8, press equals, and then divide, and it's 0.046188. 0.046188. So my z-score is about 1.73. Okay, so 1.73 is what I'm going to be looking up in my table. Okay, now if you look here, they'll say, you know, the table value is this and the area to right is this. They're not telling you how they got it. okay? It's very easy to do this in StatCrunch, so we're going to do that now. Okay, so I'm going to get out of here, and I'm going to open StatCrunch instead. Now, while that's opening, let's just talk about this. They want the probability that it's greater, okay, than 0.88. Now, you notice they had to do in the question help 1 minus. You're not going to have to do that when you use StatCrunch. We can actually find the area to the right of our z-score. So again, my z-score is about 1.73. So to do this, I'm going to press Stat, Calculators, Normal. Okay, and again, I have to go back. I keep forgetting. 1.73. I'm going to change my value here, right here, to 1.73. Okay, now if you look right now, it has everything shaded to the left, correct? And this is what you would be looking up if you had the standard number table. Okay, it would give you this area here, and you'd have to subtract from 1. But in StatCrunch, you can change it to be the area to the right. So if I look now, my area to the right of 1.73, which is the z-score for the 0.88 I was looking at, is about approximately 0.0418. And let's see if that's what they were getting here. Yes, 0.0418. Okay, so for this one, letter C, what you're going to do is you're going to take this 0.76 and find your z-score. So 0.76 minus 0.8 divided by your standard deviation, 0.046188. Get that, round to the hundredths place. And then you can do the same thing using that z-score and find your area right here in StatCrunch.